To thank you for joining today's product launch. We're excited to bring the Velo vertical turbine to our water management product portfolio. And today, Long Fane will be presenting on how this can fit into your applications and for your customers. So Long is an applications engineer manager for Velo based out of the American Marsh Pump Facility in Collierville, Tennessee, where he leads technical support, product application, and engineering solutions across a wide range of pumping technologies. Now, with extensive experience in pump design, performance optimization, and customer application support, Long bridges a gap between engineering expertise and practical field solutions. So, throughout his career, Long has worked closely with engineers, distributors, and end users to ensure pumping systems are designed and applied for maximum efficiency, reliability, and long term performance. His experience spans municipal, industrial, and commercial applications with a focus on the vertical turbine, end section, and our split case pump technologies. So, as a recognized subject matter expert within Velo, Long is passionate about training, knowledge sharing, and supporting the next generation of engineers and operators in the pump industry. So, join us for the next half hour as Long discusses our newest product, the Velo vertical turbine. In the meantime, if you have any questions, we will be holding questions till the end. So feel free to add them to the chat box or the Q&A, and we'll ask all the questions at the end. But thank you for joining us. And Long, if you can go ahead with your presentation, please.
Thank you, Tina, for the introduction. Good afternoon, everyone. Hopefully, this time is a good time for all of the time zone to join us in market launch for the Velo vertical turbine. My name is Long Fan. I'm the application engineer manager at Velo, supporting the vertical turbine lines. And let's dive into it. So let's talk a little bit about the vertical turbine and benefits that we are offering. For standard vertical turbine pumps, we offer both open and enclosed line shaft design. We design them in module in stages, so we can adding stages as your total dynamic has required. For up to 15-inch bowl, we enamel lining, have the enamel lining for up to 15-inch bowl for vertical turbine. For standard construction, we offer cast iron bowl, bronze or stainless steel fitted for vertical turbine. And for the axial and mixed flow, For the axial and mixed flow pumps, we offer cast iron bowls, only bronze fitted at the moment. We offer semi-open, open, and enclosed impellers. For bearing retainers, we have two styles. One is drop-in and up to 12 inches of column, and welding is larger than 12 inches of column. Threaded or key line shaft up to 2 and 15/16, and beyond 2 and 15/16, our stand will be key line shaft couplings. Threaded or flange column pipes, we offer packing or mechanical seal options. Cast iron or fabricated steel discharge head, and we also offer suction can or barrel. As for the NSF vertical turbine, is inherit most of the standard vertical turbine features, except for we are listed with the NSF NC Can 61 drinking water and 372 lead-free certified materials. At the moment, these NSF pumps are only available in open line shaft and enclosed impeller design combination only. The NSF certified epoxy coatings, we have a wide range. Our standard will be Thinamic and 140 Portapox, but there will be a range of other coatings which I'm gonna elaborate later in the later slide. As for the overview of the vertical turbine lines, we have 5 different models, style. The first one is the open line shaft, typically in the short sets. This is our terminology for open line shaft, water lubricated short set. Anything that between 20 to 35 that fit in a truck that fully assemble. So these are open line shaft vertical turbines. And we also have the enclosed line shaft vertical turbine, the second style here. typically for deep set or lubricated well pumps. And we also offer we also offer the fabricated vertical turbine where you have a can or barrels, and then you have fabricated head, flange columns. We also offer the submersible style where you have the motors on the bottom of the bow assembly, and we have the head, miter head, discharge head on top above ground here. And finally, we also offer a large the AF or MF or axial flow, mixed flow pump for large flow and a low head here, normally typically in 1 or 2 stages. So the combination of these 5 style vertical turbine lines give us over 150 plus models, ranging flow from up to 30,000 GPM or 6,813 cubic meter per hour. Our head up to 1,000 feet or 304 meters. Any bolt ranging from 5-inch to 42-inch, and the discharge flange can range from 125, class 125, 150, or 300. Pack or seal, like I said before, enclosed semi and open impellers. So these are the snapshot of when we put them all into the flow and head. These are the ranges of our vertical turbine below vertical turbine line. So let's dive into a little bit of, so as for open light shaft, product lubricated, let's take a look at the anatomy of the bow assembly. We have the number one is this bow shaft here, and it's keep once the bow shaft here, and then the top discharge case bearing number 2, and then you have the bearing inserts right here, the discharge case number 4, and bottom, and then so 3 is the top discharge, the 2 is the top discharge case bearing, and the 5 is the bottom discharge case bearing. You have 7, the bow, and then the 6 is the bow bearing. 8 is your impellers. 9 is impeller wearing. This is optional. 10 is the collets. The collets up to 16-inch bow. Our standards is a taper style collets to lock, taper lock basically to lock the impellers with the shaft, and above 16 bolts we're going to use keyed for connection. 11 should be the O-rings for seal, and 12 will be your bow wearing. This is optional, depends on different applications. 13 your sand cap to keep the debris, the dirt out of the suction bearing. 14 you have in the 15 is your suction case, and the suction bearing is optional, typically for the water pit or water sump, but for those are common for those for bell application, but bell is not needed or not required for a well pump. So the enclosed light shaft is similar to the open light shaft, everything from 4 to 16 down here. The only difference is 1, 2, 3. Over here you have over here you have the number 2 is what called inner columns adapter. It's acting as connecting the suction case to the enclosed tube and the light and the shaft bearing on top here. So below these are the bow shaft. Above this will be the enclosed tube. So this too is very important for the inner column adapter to connect these two two assemblies. The submersible configurations, as I said before, the motor will sit. Everything is the same from 5 to 14. The only thing different will be the motor will sit on the bottom with the help of the help of the motor brackets. 16 is your suction bearing. 17 your shaft. And another differentiation is the top 1, 2, 3. Here you have the stud and the nut to lock it in place. That have the number 3, which is your upthrust plug, and number 5, which is your upthrust disc. These two help to prevent the upthrust when the motor starts to keep the shaft in place. For impellers, and so we have 4 different styles of impellers: the enclosed, semi-open, mixed flow, and fully open. For propeller and axial flow, for impellers connection, like I said before, the collets for collets is up to 15-inch and smaller, and above 16 and larger will use a key for connection to the assembly. On request, that doesn't mean that impeller cannot be used key for the smaller size, but it's economically impractical to use key. But on request, we can also use key for the smaller size of bow. For the mixed flow, 8-inch and 10-inch mixed flow bow size, we'll use collets, and 12 and larger, we'll use key. For the open axial flow, we have 8-inch to use collets, and anything 10 and larger, we'll use key for connection. So these are the line shaft coupling, and there's two styles. One is a key. Key is basically from 1-inch to 4-inch, spanning the entire range of the shaft. Threaded is only available on the smaller diameter shaft from 1-inch to 2 and 15/16. The open line shaft product lubricated. So these are some of the configuration for column and line shaft assembly. Over here, you see that we have the column to 1. The column's number 1 here. With number 2 is your line shaft coupling. Your 3 is, so this is a line shaft. It's a line shaft. This is threaded line shaft coupling, and you have a thread and couple columns. For the small, for this size, this configuration, we have a thread column with the drop-in spiders, and 4 is your bearing inserts. Over here, you have a flange column connection with a threaded line shaft and the drop-in spiders. Below here, you have a flange column with a welded-in spiders. The enclosed line shaft, oil or water lubricated. Over here, we show an example of a thread and couple columns with a rubber spider, or we call it black widow spider in the pump world. Look, this is your the enclosing tube is number 3 here. So this is another configuration for the enclosed line shaft with rubber spiders. Over here, you can see the rubber spiders example. Let's talk a little bit about seal. So we have for sealing application for sealing, we have in-house type A10 or A20 seals, depends on the pressure rating. For A10, it's maximum pressure up to 150 psi, and then for A20 type, the maximum pressure up to 4 to 25 psi. For a packing seal, we have two types. One is low pressure. Over here, you see the Zergrease fitting number 4. I've greased to is allowed grease in this compartment to lubricate the seal, and you have packing to allow leaking. And packing water have to leak. So these you see this little shaded here is your packing. And the difference from a high pressure pack to a low pressure pack is just this assembly right here from 12, 13, and 14. Those are the pressure relief line to protect the internal. So when when the pressure is high enough, then it will trigger these pressure relief through this relief line. That's the only thing different. As for enclosed tube tension assembly, this is for tension tube kits. So I'm not sure why it keeps jumping. Sorry about that. So tension tube kits, you have the compartment A here, which is your tension bearing, screw into C to pull C. C is your enclosing tube. So pull it to a tension. You see these. You have this this pipe here. We call it the. So that E is a tube oil, because by gravity, oil will be drip down into this shaft through this. You see this curvy line is where it's a cutout of the shaft so that oil can be dripped down to the shaft and lubricate the shaft. So that is a tension tube kit for oil lubrication. And for water flush, it's similar design. The only exception is you have J, which is your tubing water flush that connect to an external. External. So water is pressurized, and if we push into this compartment to for cooling and lubricate the shaft. And similarly, A screw into C, which is your enclosing tube, and pull it in tensions proper for proper tension of the enclosing tube. And you have so very similar to the oil lubrication, except for this assembly J here, where you have an external water flush line into the system. So the tension tube kit for these tension tube kits for oil and water lubrication is suitable for column pipe setting less than 300 feet. But what if we have a larger than 300 feet? Then we will have what is called strap tube kits. These are robust design, heavy duty, that can bury the weights of the columns. So basically, you have a similar concept. E will screw into A. A is your strap tube to put in tensions, and then you adjusting the B to squeeze this B, which is your seal nut, to seal the seal rings for sealing, proper sealing. So this is all lubrication. Usually you have the oil IM that by gravity we introduce oil into this shaft to lubricate the shaft. And the same concept, but this is water flush so we have an external flush line that go into this to lubricate, and the rest of them are similar to the oil lubrication. Discharge head type, we have 3 different discharge head. We have cast. It is what it is. It's a cast head. For a fabricated head, we have F or L. The only difference is for the L type we have we have a ANSI drilling. But normally it's a round base ANSI drilling, but the typical regular fabricated head is the F style. The T type fabricated head here is used for barrel application, where you have a suction inlet in the barrel, and you have this T type fabricated head. The discharge head, typically for cast discharge head, we have 4-inch up to 4-inch, 16-inch, 8-inch to up to 16-inch. In the 14, what I put in bold here, the 14 and 16 in bold is you gotta have the flange, work with the flange columns. But any size 4 to 12, we can have a threaded columns here. ANSI B16-1 class 125-pound flat face discharge flange for the cast discharge head. And for the fabrication version, you can have the flange up to 150 or 300. Raised face or flat face flange. Below standard for all of the fabricated head, we'll perform motor analysis with FEA performed on every head and motor assembly, basically above ground features. The column pipe setting limits for cast discharge head up to 500 feet. We have a direct connection, so we thread direct into the head, but between 500 and 750 feet, we recommend to use a steel hanger flange for the support, mainly for the support of more robust and support of the weight of the assembly. For fabricated discharge head, it can support up to maximum 750 feet of column settings, and above 750 feet is doable, but require engineering approval on a case-by-case basis. So I just cover everything about the regular vertical turbine. Now let's talk a little bit about the NSF certified VLO vertical turbines. So this NSF certified VLO vertical turbine inherit most of the features of the regular turbines, but since it's an NSF certified pumps, um, we only narrow down to 67 models. It will do all the full range of flow up to 30,000 GPM, up to 1,000 head. But the bowl ranging from 6 to 42. It has the NSF ANSI CAN 61732 certified materials, left in material construction. We can have class 125, 150, or 300 discharge flange, pack or mechanical seal, open light shaft, and water lubricated, and closed impeller. At the moment, we can only offer open light shaft and with the combination open light shaft and closed impeller only at the moment for NSF certified pumps. We optional, we can also have a suction barrel application there. So on this table, you see is one of example of most of the. So every pump manufacturer, NSF certified, they have their own certified material of construction. So as for VLO, these are our standard offering. For bow, class 30 cast iron, impeller 304 or 316 stainless steel. Optionally, we can also offer aluminum bronze C952 or nickel aluminum bronze C950A impellers. Suction case bell, we have class 30 cast iron. Discharge case, ductile iron. Bow suction wearing is a C954 aluminum bronze. But as for bow and suction bearing, we also have the additional option CA 9835 bronze or bismuth tin bronze. For taper lock, bow shaft, line shaft, coupling, and all that bearing insert, the material construction is 416. And for line shaft bearing insert, for soft bearing, we have Nitro NBR 6231-70, or we can have Vescanite hard bearing. For spider, our standard 304 stainless steel, column pipe steel. Discharge head, again, same cast iron or steel. Strainer only offer in 316 stainless steel. The bowl assembly for NSF VLO vertical turbine pumps have similar, but there are some restriction because of NSF certificate. So we have enamel lining for bowls up to 16 inches, O-ring sealing between bowls for up to 15 inches. We have replaceable bowl wearing for all models, standard for all models, but optional replacement impeller wearings, not standard on all models. Only offer only in enclosed impellers. No semi-open, no open impellers, just only enclosed impellers. The colorless impeller attachment is up to 15-inch bowl, and beyond that, it will be keyed. We have optional basket tie strainer, only 316 stainless. So these are let's talk a little bit about the column and NSF certified columns. Only applicable for open line shaft design only, no enclosed line shaft, just open line shaft. Water lubricated bearing fluid for drop-in tie bearing retainers, 12-inch and smaller. We can have threaded and couple or flange. For column size of 14-inch and larger, that will be a welding tie fabricated steel. It must be that we must use a flange column. For shaft size of 2 and 15/16 and smaller, we use threaded coupling, and anything greater than 2 and 15/16, we use key coupling. Like I mentioned before, we use the rubber line shaft bearing insert or Vescanite hard bearing. Discharge option, we can have cast with 125 flat face flange or fabricated steel discharge head with class 150 or 300 raised flange, FL or T-type. Here you see an example of the cast head on the bottom left here, and the top right you see the fabricated head. Looks like an L style because you have NC drilling. For sealing options, for packing, we only at the moment we can only offer Chesterton 1725A example here on the picture on the right, and for mechanical seal we can offer either Chesterton or John Crane. Our preferred vendor with Chesterton, as you can see here, 150 general duty single cartridge seal, the very first pictures, and you got standard cartridge seal 155, heavy duty 180, and the most robust seal is a split seal 442 series. Could be a non-cartridge or cartridge. The only thing different is the C is a cartridge. So cartridge is basically a newer design, with the purpose of ease of installation in mind. So it come with a so with convenience. So the 442C for convenient, or the cartridge seal, split seal. They all split seal. For coating options, our standard coating is the Thinamic N140 Portapox Plus. We also have a fusion bonded coating like Scott Code 134 or 206N. We also have other lines of coating, Thinamic coating, 21 epoxy and 22 epoxy. Applicable surfaces can be applied. These is IDOD of bowl, IDOD of columns, ID of head, OD of the packing housing or lower seal housing, ID of suction barrel. So basically all the weathered surfaces that are in touch with the water. So some of the applications is, this vertical turbine can be used for example, like Memphis International Airport for stormwater pumps. This is mixed flow, I believe it's mixed flow pumps. And we can use for water treatment plant. One of example here you see is Lancaster's, California. Or we can use this vertical turbine in pumping river water for agriculture surface, agriculture application or anything else. So with that, hopefully I provide some information for you guys.